Right, welcome back. We're on page 6 of the primer and we'll have a look at the next topic, transposition. This simply means moving letters around so you get the letter that you're interested in by itself and all the other material is on the other side of the equation. Okay, if we have a look at some of the examples in the book now. Force equals mass times acceleration. We're using the letters, so F equals ma. Now if we want m, we don't want a on that side, so I can take it to the other side, but I must remember if I change side I change sign. So the set one there here is this, F over a equals m by itself. The a here multiplies the m, take it across, so it must divide, and there we go. Quite straightforward. That's a very easy one and can almost be done in your head. Oh, excuse me. Okay, let's have a look at the next example. B equals h plus 4 pi l, and we're asked for the letter L, so we need L by itself. Now what most people don't realize too quickly is that there is a rule that you can use in transposition, and this is it. It's good old BIMDAS. Now remember that from the previous section. However, one little change applies and we have to put BIMDAS in reverse. Okay, so in other words, if I want to change the formula around, I do addition and subtraction first, I do multiplication and division next, then I do indices, and anything in the brackets comes last. So this is an important feature that you need to remember. So we need L. Okay, step 1. Is there any addition or subtraction here? Yes, the h is added on, so I get rid of that. B minus h equals 4 pi l. Now the h is added onto this side, so it's subtracted from that side, so we're following that rule. Step 2, I don't want the 4 pi, so if I get rid of that, which multiplies the l on this side, bring it across here, then it must divide. So finally I get this. And that in fact is what the answer is in the back of the book, so that in your down the bottom of the book there. So finally you have the correct answer. Similarly with the one at the bottom, you've got this v equals u plus a t. Now if we want the letter t, then we apply BIMDAS in reverse. So step 1, v, I get rid of the u. Why? Because the u is added onto the term that we want. Take it across. So finally we have that. And the next step, v minus u, I don't want the a, which is multiplied on this side. Take it across so it'll divide out on this side. And finally, in the very end, we have the answer at the bottom of page 6, which is the correct answer. Following the rules of BIMDAS, you must do it in reverse. Okay, as long as you do that, you'll be all right. Let's have a look at another one. They do get quite complicated, some of these problems, but BIMDAS solves all of them every time. You must follow the rule implicitly. Here we go. So we've got this one. 2 pi rh plus 2 pi r squared, and if we want the letter h, okay, I notice that h is there, but I don't want this term. So step 1, I get rid of what I call the rubbish. I can take all that across and leave the term that I want here. H is there, this comes across, it was added there, so it's subtracted here. Step 2, I don't want the 2 pi r, I want to get rid of that to leave the h. So if I bring the 2 pi r across, I must change its sign of the operation. In other words, it's multiplied there, so simply divide it out. And if you have a look in your book, hey presto, there's your answer. The more you do of these, the quicker and easier they will become. Let's have a look at this one. Now this one is a very famous one. This is your temperature, relationship between Celsius and Fahrenheit. Show you a couple of things here. This is quite good. Okay, now clearly we can put a number in for the Celsius and get the Fahrenheit, or put a number in for the Fahrenheit and get the Celsius. So supposing we're after the letter F by itself. Okay, I'll see if I can show two ways here. This will be quite interesting. There's two ways to do this, and you can choose which one you like. All right. Method 1. Okay, anything outside the bracket is multiplying the bracket, so if I take it across to the other side, then 9c has to be divided by 5. Now the interesting thing here is that you'll notice that the 5 multiplies the terms in the bracket. Once the 5 comes across, there's nothing basically other than a 1 outside the bracket, so the brackets disappear. So a lot of people like this method because of that. The next step from here is trivial. The next step now becomes 9c over 5. Now look, here's a minus 32. Let's get rid of it to the other side, and wow, we've got the answer in 2 quick moves. Okay, so let's have a look at that one again, because there's some little tricks here. When I divide by the 5, I take this 5 across. What I'm really doing is I'm dividing both sides by 5. So 5 into 5 goes 1, but if there's 1 outside the bracket, then the bracket is redundant. That's why this is an attractive method. That comes across, nothing then can multiply the bracket other than a 1, so the brackets disappear. Lots of people like that, but let me show you method 2. So in an exam, if you've got 2 methods, use the one that you prefer to show the examiner, but then use the other one to check. Watch this. 9c equals 5 bracket f minus 32. Now this is the same as 9c equals 5 times f is 5f minus 5 times 32 is 160. So if I multiply this out, this is another clever way of getting rid of the bracket. So I'll put a star there which corresponds to the star here. I've got rid of the bracket by dividing the 5, getting it to the other side, or multiplying out on the right hand side. Now I need a couple of steps to get f. Watch this. The 160 comes across. I do the addition or subtraction first according to BIMDAS. This now is 160 equals 5f, and finally I divide both sides by the 5, get rid of the 5 to the other side, and hey presto, there's your answer. Now some of you students might think, but hang on, that's not the same as that. But it is, because 9c over 5 can be written like that, plus 160 over 5 is the same as 32, and they are completely and utterly identical. So this is a clever way. Now this will come up again in a more complicated example that I've got, okay, when you're dealing with resistance and temperature of time, etc. I can show this in a few minutes, but let's just go over that. Okay, have a look at that and see if you need to revise that again to make sure you understand what's happening. Okay, down towards the bottom of page 7 we have another example. This time we're dealing with fractions. So we have t equals 2r over 3, and the examiner has asked you to find r by itself. Okay, the quick way to do this is to realize that this is t over 1, and the rule that you've used before is the cross multiplication rule. So step 1, 3 times t is 3t, 1 times 2r is just 2r, and finally step 2, if I want r I get rid of the 2, bring it across, and there's my answer. You can check that at the bottom of your page there. Remember, change side, change sign of the operation. So 2 comes across, divides it out. Very simple. That's an easy one. You can do it quite quickly. Now, what happens if the examiner gives you a problem that has a square root? People don't usually like these, so I'll show you how to deal with this one. P over little r. Okay, and the examiner is asking for little r. Now, the square root here is an operation. To oppose a square root, you square both sides. I'll write that in, and you can remember that one. We square both sides. So step 1 means this. If I square c, I get c squared. Now watch, if I square this, what I'm doing is this. Squaring it. And that is the same as p over r. The square cancels the square root. Okay, so step 2, c squared now equals p over r. If I want r, very quickly I put that over 1, cross multiply, 1p is p, rc squared. Okay, this is my cross multiplication rule to give me step 3, and finally step 4, I want r, which is going to be p over c squared, which is your answer. Okay, change side, change sign, as we did before. Now, if you've only got 3 terms, page 8, we talk about something like this, 2y divided by 3 plus r. So remember, if there are only 3 terms, make the 4th term by bringing in the 1. And again, use your cross multiplication rule. So step 1, 1 times 2y is 2y equals x multiplied by 3 plus r. And I put it in brackets just to make sure that I don't miss any term out. Okay, just got to be very careful. The x has to multiply everything that's under here. Okay, so just to remind you, there's your cross, and you multiply them together. So step 2, now we're after r, so I've got to get it out of the bracket. So again, you can use either dividing out by x or multiplying this out. I'll multiply this out. Okay, so we've got 2y equals x times 3 is 3x, x times r is rx. Okay, step 3, I want the r term, I don't want this, so if I want that term, I'm going to get 2y minus 3x, that comes across, equals rx. I want the r, so finally I can rewrite this as 2y minus 3x, take the x across, and I've got the r by itself. Now, some of you must say, oh, but hang on, that's not quite the answer that you've got in the book, but it is. If you look at this, this can be rewritten in the following way. This is the same as 2y over x minus 3x over x, and the x's cancel. And you'll notice that in fact it's exactly the same as the answer in the book. Okay, if we have a look now, this one's a little bit more complicated. Same procedure, we've got 3 terms. D equals x plus 3 over x minus 2. And the examiner says, haha, we want the letter x. Now you think, ooh, you've got to be careful because x is in the denominator and the numerator. So step 1, I'll put this over 1 and use my cross multiplication rule. So we've got x plus 3, this is step 1. 1 times x plus 3 is that, equals d bracket x minus 2. So we're okay. For that, we've got rid of the fraction, and this is the right order to proceed. X plus 3 now equals dx minus 2d. All right. How I've got that is simply multiplying these out. Now we want the x, so I must bring the x's to one side or the other. Okay. It doesn't matter which way I do it, but I must decide on one or the other. So what I'm going to do is step 3, I'll bring this x across. So effectively I'm going to swap that and the minus 2d. Okay, we're going to swap them over and watch what happens. This becomes 3 plus 2d, notice it's minus on this side, plus equals dx, it's plus x there, minus x. So have a look at that little stage. I've done a double swap. This has come across and that's come across, and the signs have changed. Okay, so now we've got 3 plus 2d here, and I notice that x now is on this side. I can bring x out as a common factor and leave that. Now let's have a look how I've got that. I look at this and I say there's an x term there, there's an x term there. X into dx goes d times, but x into minus x goes minus 1. So bringing the x out, I leave the other terms in there. Now that's important for you to remember that, because sometimes you are asked in questions to create a set of brackets and remove the common factor. So I'll put this down, common factor here, and that'll remind you that x is the common factor. Finally, step 5, I want x by itself, I get rid of the rest. So I have 3 plus 2d equals x. I want the d minus 1 not to multiply on this side, but to divide on this side. And there is my answer. That's exactly the same answer as you have in the booklet there. Now, just to show you, some people might go back and say, okay, happily here, what happens at step 2 and step 3? Let's look at this in a little more detail. X plus 3 equals dx minus 2d. Now, I swap these over. What happens if I bring this over instead? Well, I'll get this. X minus dx equals minus 2d on this side minus 3. This is a little bit more awkward because you've got negative numbers, but still the same process. Notice that x is on the same side here, so I bring this out. X, make a common factor of it. Now I get 1 minus d. But here, this is minus 2d minus 3. So x, you'll say, oh, look at this. When I get rid of this, minus 2d minus 3 over 1 minus d. But that's not the same as that, surely. But it is. Notice that in this case here, the top is positive. Here, the bottom, the top is negative. Here, this is d minus 1. Here, this is 1 minus d. So it's in the same proportion. If you wanted to check and put numbers into d, you'd find out that that and that are completely and utterly identical. Okay? The way to check, if you're ever in doubt, for those of you that are good at maths, is to multiply the top and bottom by minus 1. Watch this. Minus 1 times that gives you 3 plus 2d. Minus 1 times that gives you d minus 1. And wow, that's amazing. It's exactly the same as that. So this little trick about multiplying top and bottom by minus 1 will in fact give you the same answer. They are completely and utterly identical. That's only if you're very good with your maths, okay? But if you're not, you can use that technique to confirm that the two answers are in fact identical. Now, sometimes you get fractions. People don't like fractions, so let's have a look at this one. Bottom of page 9, if you're dealing with fractions, 1 over x equals 1 over y plus 1 over z. Okay, now we want z. When the examiner asks you for z, he doesn't want minus z, and he doesn't want 1 over z. He wants plus z. So it takes a little bit of working out. So what we have to do here is to get this first of all by itself. So what I would do is this. Okay, yep, step 1. 1 minus x. I'll take this across using the rules that we've had before, and I've got at least z by itself now. Okay, step 2, I need a common denominator. In other words, something that x and y will go into. If I don't know what they are, I just multiply them together. Okay, now x into xy goes y times 1 is y. Y into xy, I'm dividing it in, goes x times minus 1 is minus x equals 1 over z. Now at that stage, that's about as far as you can go for both sides. So now we cross multiply there. Okay, we can do that now. Okay, quite simply. Or you can just tip it upside down. That's another quick way. So you can say Z will equal xy over y minus x. Okay, and if you have a look in your book, I think on page 10, there we go, we've got it, xy equals, z equals xy over y minus x. Just to check that when you cross multiply you get that, xy times 1 is xy, and z times y minus x is that, so therefore z will equal xy over y minus x. So